Okay, I wanted to do a short video on some of the technology I have in the coop. I had electricity ran out to my shed, which is about 30 feet from the coop. So I just continued it on so I could get electric out here. I'm about 200 feet from my house, so I wanted to put a couple webcams out here. And the way I did it was with a router that I flashed with DD-WRT. It turned it into a wireless bridge, and I really have a pretty good connection to my home network in my house. Initially, this is actually the third router I've tried this with. The first one was an old Linksys G router. And I'm sure you know which ones I'm talking about if you're into this at all. Those blue ones with the two antennas on the back. They were great routers. I just didn't get the range because it was just a G router. I had tried one of those Yagi antennas, the cheap Chinese ones from eBay, and that didn't seem to really help. So I went to an ASUS router, flashed that. That was an N router. I think that was defective, because that didn't work very well. What I ended up going to was a Linksys E1200 that I got on eBay for, I don't know, $15 or $16 used. I flashed it with DD-WRT and connected it to my home network, so it's acting as a wireless bridge. And there's plenty of information, either Google it or on YouTube, that'll let you know how to do that if you're interested. I have two webcams. One is here in the coop that I can kind of just keep an eye on what's going on out here. The other is in the run, and I'll show you that in a few minutes. I do want to show you the automatic door. If you look on YouTube, there's a lot of these doors. I mean, people make all sorts of different variations of it. With my particular variation, I used an Arduino microcontroller because I have internet out here now. I used an Ethernet shield to connect it so I have web access to it, and I can show you that in a little bit as well. The mechanicals for this particular design were a little bit different than what I've seen on YouTube. I decided to use a rigid threaded rod and a gear motor. A lot of people, from what I see online, just use they'll use a wire that winds or a motor that winds a wire up and down, and that doesn't seem to secure it. There's been a few that I've seen that have like a latching mechanism that's really quite ingenious, but I wanted to keep it simple. This doesn't need to latch. It holds in place as soon as the motor stops, so it can't be lifted up by any predators. I have two limit switches on this design. They're both magnetic. I didn't initially on some earlier versions of this, I used micro switches, and those just never seemed to work exactly too well. This design isn't as precise as I would like it, but it was a good start. The micro switches were a little bit more precise, but they weren't as reliable, and I was looking more for reliability. And if the door, stops short, a half an inch or a couple inches from the top, it's not really too big of a deal. It's still coming up 11-12 inches, so the birds can get in and out. I may try to come up with something, and if you have some suggestions, mention them at the bottom on how I could get that a little bit more precise. And like I said, I didn't want to use a mechanical switch. One thing I did do, and I did notice, a lot of people use wood for their doors, and I was no different. I did notice that sometimes the wood will swell depending on the weather. and the door can get stuck. So I ended up cutting 2 grooves on either side or either edge of the door. I don't know if you can see it there. The grooves, or within the grooves, I put 2 or 4 altogether, 2 on each side, nylon wheels from a screen door, a sliding screen door roller. And what that does is it keeps the door from canting. So I mentioned earlier the designs that I've seen online that have a string or something that pulls them up and down. You know, those doors can kind of get a little off kilter and cant sideways and get stuck. And with a string, they're not going to move anywhere. With a wheel on each edge, that little wheel, and I put one here, down here, over here, and up there in the groove. With a wheel in there, it keeps it straight. It doesn't move or want to get stuck. So that was kind of, with the mechanicals, kind of an important thing that I wanted to do, just for reliability. The door opens and closes. The gear motor is fairly slow. It takes about a minute, minute and a half for it to open and close. And I can hopefully show you that later. The brains, and I'm going to improve on this, I think, or do something a little bit different in the near future. On the right, I have a Arduino with a Ethernet shield that hosts the web page that I control the operation of the door with. On the top left there is a H-bridge. The H-bridge, the function of it is to basically control which direction the gear motor goes in to raise and lower the door. And then at the bottom, with those connectors, basically they're just the voltage dividers for the sensors. There's 2 door sensors and the sensor for the to detect light, and that runs out underneath the run, so it's protected from snow and rain and that type of thing. Currently on this particular design, I had 2 power supplies. One runs the Arduino and the other runs the gear motor. I plan on my next version of this, hopefully consolidating them, so I just have one plug to deal with. Okay, here's the outside of the door. Just above it, I ran the sensor from the Arduino. It's just basically a voltage divider between a resistor and a photoresistor that tells the Arduino if it's day or night out, or how much light is outside. I put it under the run. It protects it from the elements. It doesn't get covered up or snow packed on it or anything like that. As I mentioned earlier, you can kind of see where the door didn't quite open up as far as I'd like it to because of the door sensor. And like I said, if you have any suggestions, I'd love to hear them. Also, I mentioned, here's the other camera, the webcam, and that's the technology end of it. I plan on doing another version of the door. I want to integrate a Raspberry Pi. That'll allow me, I think, to do a few things that the Arduino itself won't. Okay, I real quick wanted to just show you the web page that I have set up. This is hosted on my local network. I do have it opened up to the outside, but I didn't want to make that address public. It just takes still shots and it updates every 30 seconds of the two webcams, so I can kind of see what's going on. Then I have a control page, and this is only available on my local network. It gives the mode that the door is in, whether it's automatic, and that means it'll open and close according to the amount of light outside. If it's in manual, I can open and close it how I'd like to, or leave it open or leave it closed. Then you'll see I have the light reading that I display and the threshold for which it, or at which that sensor opens and closes. Pretty simple page. Right now it's hosted on the Arduino, but like I said, I'd like to, if I incorporate a Raspberry Pi, move it all to that.